Good morning, dear students. In today's lecture, we will talk about the two most important parameters which are associated with an atom. And these two parameters are ionization potential, and the second one is your electron gain enthalpy. It's a type of energy changes which takes place when we add an electron or we remove an electron from an atom. So first type is your ionization potential, which is also called ionization energy. In short form, it is represented as IP. Now, the definition of IP: the energy required to remove the most loosely bound electron from an isolated gaseous atom is called ionization potential or ionization energy. Again, the energy required to remove the most loosely bound electron from an isolated gaseous atom is called ionization energy or ionization potential. By most loosely bound electron, we mean that we are talking about a valence electron. And if we want to remove the electron, then electron should be in gaseous state. Then only it will be in isolated condition. Because when we talk about gas state, then we have maximum distance between the atoms or the molecules. So here, it's your metallic atom in gas form, isolated condition. When provided IP1, means we are removing first electron from isolated gaseous atom. Then by providing IP1, one electron will be removed and metallic atom will be converted to unipositive ion M plus gas state. It's your cation. Now, if we want to remove one more electron, then we have to provide second IP, represented as IP2. So when IP2 is provided to M plus gas state, then one more electron will be removed and M plus gas state will be converted to M plus 2 ion. Bipositive ion, again a type of cation. Now provide third energy, then it is IP3. One more electron is removed, it gets converted to M plus 3, tripositive ion with the removal of the electron. As we are removing the electron from the atom, first it gets converted to unipositive ion, then converted to bipositive ion, then converted to tripositive ion. It means the proton's force of attraction or force of attraction due to nucleus will increase over the electrons of valence shell, so there will be contraction in the size of the atom. Valence shell will come closer to the nucleus. If we talk about M plus size, then M plus size is less than metal atom. Size of M plus 2 ion is less than M plus ion, and size of M plus 3 ion is less than M plus 2 ion. So in general, it is observed that IP1 is less than IP2, IP2 is less than IP3. Reason is very simple. Size undergoes contraction, and due to contraction in the size of atom, valence electrons feels more force of attraction. So it becomes difficult to remove the electron, and in that case we have to provide more energy. So here we can say that IP is proportional to 1 by atomic size. If the atomic size increases, value of IP will decrease. If the atomic size decreases, value of IP will increase. So here we can form a law. If we start moving from left to right in a period, we know it very well that effective nuclear charge increases due to increase in the number of protons in the nucleus. So atomic size decreases. So when we move from left to right in a period, atomic size decreases, as a result of which value of IP will increase. One more factor that we have to remember, if we are comparing the IP of nitrogen and oxygen, oxygen belongs to group 16 or 6A, having 6 valence electrons. Nitrogen belongs to group 15 or 5A, having 5 valence electrons. Atomic size of oxygen is less than nitrogen, but still the IP of nitrogen, first IP of nitrogen, is more than oxygen. The reason is very simple. If we have completely filled subshell or if we have half filled subshell, we know it very well that in p subshell we can accommodate maximum 6 electrons. So if we have 6 electrons in p subshell, then it is treated as completely filled subshell. If p is having 3 electrons, then it is considered as half filled subshell. So full-filled subshell and half-filled subshell are more stable. Full-filled electronic configuration and half-filled electronic configuration is more stable. So in nitrogen, although the atomic size of nitrogen is more than oxygen, but still the first IP of nitrogen is more than oxygen. Reason is very simple. In nitrogen, we have half-filled electronic configuration which is more stable. The configuration for nitrogen in outermost shell is 2s to 2p3, and for oxygen it is 2s to 2p4. So 2p4 electronic configuration is less stable than 2p3. That's why IP1 of nitrogen is more than oxygen, although the atomic size of nitrogen is less than oxygen. Then comes electron gain enthalpy. Just opposite, the energy released when an electron is added to valence shell of an isolated gaseous atom. The energy released when an electron is added to valence shell of an isolated gaseous atom. Normally, electron losing tendency is possessed by metals. That's why here I have represented general form as M. Electron gaining tendency is for the non-metals, and non-metals are represented by letter X. So it's the general representation for non-metals. So X gas, when gain electron, will be converted to X minus gas. Energy will be released because electrons carry negative charge and nucleus is having positive charge. So there is a force of attraction. So when distance decreases between electron and nucleus, then energy is released, and that energy here is called electron gain enthalpy. Remember, this process is endothermic. It requires energy, while second process is your exothermic process because energy is released. Remember, every time whenever we talk about electron enthalpy, then we say negative electron gain enthalpy. Reason? Because energy is released. Because the energy is released, that's why we are using the term negative electron gain enthalpy. More negative the value of electron gain enthalpy, more easily the electron will be added to valence shell. If between the incoming electron and the nucleus force of attraction is more, then there will be more release of energy, and that energy is called electron gain enthalpy. Now, when one electron is added, it gets converted to X minus gas, uninegative ion in gas form. Now, we want to add one more electron, and here we are adding the electron to negative ion. So definitely the incoming electron will feel force of repulsion because minus charge is there. So to overcome that force of repulsion, we have to provide energy from outside. So earlier the process was exothermic in nature. In second case, it will be endothermic in nature. It will require energy. So in second case, electron gain enthalpy will be positive. So electron added gives you X minus 2 gas. Now we want to add one more electron to X minus 2 gas. There will be more force of repulsion. So requirement of energy will increase. and will get X minus 3 gas. Again, electron gain enthalpy is proportional to 1 by atomic size. If atomic size increases, then valence shell moves away from the nucleus. So incoming electron will feel less force of attraction. So release of energy will be less. If atomic size decreases, valence shell comes closer to the nucleus. There will be more force of attraction from the nuclear side to the incoming electron and energy release will be more. So if the atomic size increases, electron gain enthalpy decreases, negative value of electron gain enthalpy decreases. If atomic size decreases, negative value of electron gain enthalpy increases. So if we see in a periodic table, when we start moving from left to right, atomic size decreases. So we can say negative value for electron gain enthalpy will increase. If we check in a group, if we start moving from top to bottom in a group, atomic size increases. So value of electron gain enthalpy will decrease. So these are the two important energy parameters related with the atom. That's all. Thank you.